before I just want to emphasize, if you guys have logged on Alex within the last couple of hours, you might have seen I've extended out your homework for chapter 2 and chapter 3. And I extended it out until the day before the final exam, which turns out to be a Sunday, the 10th. Exam in this class is the 11th, May 11th, 3:50 in this classroom.
Wait, so the homework part?
Homework for, yeah, chapter 2 and chapter 3, I extended it out. Now, the reason why I gave you until the day before the final is because I don't want you guys to spend that time on it now. I'd rather you spend time on chapter 4 material now, since that's going to become due the day before chapter 4 test. And I can, you know, kind of come to it. Alex grades overall are kind of low. So in that case, I also made them quick retakes. So you should be able to go in there and do the ones you missed to get your points for your homework. And then I will download all of that when you guys take your final, and that will be your Alex grade. Keep in mind your Alex grade is 20% of your overall grade, and your final is 20%. So they're kind of equal to each other in that sense. Each exam, I believe, is, I teach too many classes to have this exact. I want to make sure I tell you correctly. Each exam is 20%. So exams, the final is 20% and Alex is 20%. So they're all kind of evenly weighted. Your exams, though, can be replaced. Your lowest exam can be replaced with your final grade. No, 15%, because there's 4 exams, sorry. There's 4 exams in here for a total of 16% or 60%. So each exam is 15%. Question?
The chapter 2 stuff, all I see on Pi or homework right now is chapter 4 stuff.
Okay, for some reason I haven't figured out the Pi extension. If you send me an email individually, I can extend out your Pi, but I can't extend everyone's Pi out. So if you send me an email individually, I'll go in there and resend you an email saying confirm you should have access to your Pi then. For extensions, the Pi is done a little different because everyone's Pi is different. It depends on how they go through the Pi.
Oh, so maybe I didn't need to go through chapter 2.
Possibly. You should be able to go to your grade book and look at your Pi grade for chapter 2. If it's really low, send me an email and I can extend that out. Yeah, okay. Because the way the Pi works, you have to hit the prerequisites before you can go on to maybe chapter 4 stuff. So okay. If it's not a prerequisite, they don't worry about it. Okay. So they'll start you with where you're at. So if you've already met those objectives, those are just the objectives you have left to meet.
Okay.
Yeah. So it should tell you.
If it's not on there, that I don't need to worry about it.
I believe so in the Pi.
Yeah. That's what.
Yeah. So if it's not on there, you've already met it. You've already satisfied that objective. And there's 4 pieces of the Pi. So if you're in one Pi, you can get some of the pieces for chapter 2 because they're prerequisites, or for chapter 3 or whatever it works. It's a little different. So I have to extend it out individually. Okay. So if you're still concerned about that for your Pi, send me an email and I'll do that individually. But as far as homework 2 and homework 3 have all been extended out till the day before the final, and they're all quick retakes. But I wouldn't spend the time now getting them at 100% because that's just I would rather spend the time in this material so you're successful on exam 3, and then you'll have the time to work on all the material. Once we take the 4th exam, I'll extend everything out until the final so you can go back there and practice and get that done. So I do that for your guys' benefit, and then it's going to help you study for the test, help you study for the final, and then also boost your Alex grade. Any questions on that? So if you log into Alex, you should be able to see old homeworks, go in them, and quick retake them. Bump your grades up. That's going to bump your grade up 20%, which is more than an exam. So you see where you fall there. So today we're going to go over 4.4. And looking at the schedule, originally I was planning on having an online class the April 3rd. I don't think we'll need to do that since we're already on 4-4 and we're a week ahead, almost a week ahead. So I think we're going to be the next couple of lectures, we're going to be right on top of being able to review quite a bit and then also go in there and give you guys almost like a pre-test type thing, our review and our test 3. So our test 3 will be the Friday after 2 weeks from today. So next Friday, we'll go on, I don't even know what to call it, 25-year break, I don't know, celebration. So I don't think it will be too much of a benefit to do anything online. So it'll just be a free day for you guys. And then we'll have Monday, Wednesday, and then we'll take the test on Friday, all over chapter 4.
So we don't have class with them today?
We don't have class a week from today. It's the 25
Right.
celebration thing. Yeah. Classes after 1 are canceled. 4.4 by itself is not an too interesting section. However, we cannot complete 4.5 without knowing some of these properties. So standalone, there's not a lot of calculations to do. You're either expanding it out or you're simplifying, but where it really comes handy is in 4.5. And in 4.5, we're going to use these properties to simplify things to be able to solve equations. So we're going to learn the product, quotient, and power properties of logs, write logs as expressions in expanded form, write them as a single log, and then use the change of base to calculate any log base 2 of 5. We're going to be able to approximate that using our calculator. That's going to come in handy for when we need to solve for x. So to start out, how many of you have had exposure to logs before? So about half the class. So we're going to apply the product, quotient, and the power properties of logs. And there's kind of a proof I want to go through with you guys. This is the product property. The product property is saying if I take log base b of x times y, I can expand that out to log base b of x plus log base b of y. The proof here, let's let m equal log base b of x and call n log base b of y. In exponential form, I could write that as b to the m is x, and b to the y, oops, sorry, b to the n is y. Okay, you guys, the base to the exponent equals x or y. Would you agree that if I take b to the m times b to the n, that gives me b to the m plus n? You guys remember properties of exponents? If I have the same base and I raise that to a power, I add the powers. So if I have log base b of x times y, that's going to be m plus n, which ends up being log base b of x plus log base b of y. You can only do this when you have the same base for your log. And of course, if you can go from the left-hand side to the right-hand side, you can go from the right-hand side to the left-hand side. So we're going to take a single log and expand it. We're also going to take an expanded log and put it under a single log. So here are some 4 examples here. Log base 2 of 8x, I want to write them as a sum and simplify if possible. So this proof is just kind of the generic why we can do this. We can do it because b to the m times b to the n is b to the m plus n. So log base b of x times y is log base b of x plus log base b of y. So how could I rewrite log base 2 of 8 times x into a sum of logs? Good. Yeah, log base 2 of 8 is 3 because 2 cubed is 8. So this would be 3 plus log base 2 of x. Eventually, we're going to go solve for x. And it can be beneficial to have it in one form or another. So do you guys see that? If I'm multiplying within my log, right? So you see that they kind of stress the parentheses here. That's the sum of logs.
How did you get the 3?
Because log base 2 of 8 is 3. Because 2 to the third is 8.
Okay.
Saying what power of 2 gives me 8?
Right, 3.
Yeah, some of these you can simplify pretty easy. Some of them they won't simplify. Like log base 10 of 12 doesn't simplify. But log base 2 of 16 will be 4. Log base 4 of 16 would be 2. You guys see that? So what's our next log base 4 of 16 times a can be written as log base 4 of 16 plus log base 4 of a. So right now we're just writing them as a sum. Eventually we're going to be solving for a or solving for x. You guys see that? B is not too interesting. It's just ln of 5. ln of 5 plus ln of x plus ln of y. They have to be multiplied together. A common mistake here is if I take log base b of x plus y, that does not equal log base b of x times y. Don't do something like that. It's probably the most common mistake I see in this section. Students do something like that. It has to be log base b of a times b is log base b of a plus log base b of b. If the plus is within the parentheses, you can't separate them. It has to be multiplication. And we'll go over some other examples. What about b? Log of 12 plus log of c plus log of d.
And when there's no base presently,
It's 10, yes. So we don't have to write the 10.
right.
But if it was there, it's fine. If it's there and you don't write it, it's fine as well. You can drop it if it's 10. It's understood log base 10. And that's like here, this is really log base e.
Right.
We just write ln. So does anyone have any questions on the product property? If you have log of x times y, you can write that as log of x plus log of y. Be very careful though. Like I said, log base b of x plus y, that's it. That does not equal log base b of x times y. Log base b of x times y equals log base b of x plus log base b of y. So this will come up and you're done there. There's nothing to simplify. It's already simplified. You can't go anywhere there. Though we'll get to it because there's an example where it comes up. So if I want to write x to the y power, or x over y, I could write that as x times y to the minus 1, right? And that kind of comes up here with powers. But when you're dividing two numbers, you subtract them, which makes sense. If I have b to the x divided by b to the y, I can write that as b to the x times b to the minus y. And then I would have b to the x plus a minus y, which is really b to the minus y, or sorry, b to the x minus y. You guys remember that for properties of exponents? Dividing like bases, you subtract the exponents. You're going to do the same thing with logs. You're going to subtract the logs. We're going to eventually put all three of these things together. Powers can be pulled out front to be p log base v of x. So log base v of x to the p power can be written as p times log base v of x. So an example here, if I have log of x squared, I can write that as 2 log of x. Key thing to remember, the power has to be on the whole base. So if you have a plus b squared, then you would have 2 log of a plus b. Your base is what kind of stays in this parentheses. So let's look at these 4 examples. How could I write log base 3 of c over d?
Log base 3c minus log
Yeah.
base 3d.
Yeah. Log base 3 of c minus log base 3 of d. Change my thickness here. What about this a?
Log base 6a minus log base 6t.
Good. Right, not too, typically we drop the parentheses when we only have one term. In a little bit, we'll look at somewhere it's like a plus b, and you want to be careful to put those parentheses there. It's clear what you see what's going on to write this as log base 6 of 8 minus log base 6 of t. Yeah. Especially if you're not very careful where you put your bases at. Sometimes if I write this log of 6, 8, I might get confused what it is. Yeah. So using parentheses is a safety measure for that. However, if you look at the answers in the back of the book, a lot of times they'll drop the parentheses if there's only one term. What about b?
Log of x minus 3.
Log of x minus log of 1,000, but log of 1,000 is 3, right? Because it's saying 10 to what power is 1,000? Do you guys see that? What about b?
ln minus ln of 12.
So we'd have ln of e minus ln of 12. What is ln of
Do
e?
we have to put the e there?
You would have to put the e because it simplifies to 1. It cancels each other out, yes, but it's still
goes
1.
to the 1, okay.
Because they're inverses of each other. So it's not 0, it's 1. So if you don't put it, it doesn't make sense because you have to have ln of something. It's a function like sine, cosine, tangent, those are functions. You have to put something inside them. Here we're putting e, which ln of e is 1.
Is that ln of e up there?
This,
Where the arrow is? Yeah.
it's saying that it goes to 1.
What is under the arrow?
This is ln of e.
Okay.
And then I was saying this goes to 1. ln of e is 1. Just like log of 1,000 is 3. You guys see that? So the power rule here, there's two kind of ways to present it. You guys know how to write the 5th root of x squared? It's another way to write the 5th root of x squared as a power. So this would be ln of x to the 2/5, right? The nth root of x to the m can be written as m or xm over n. So what's another way to write this? Good job. 2/5 ln of x. Because the power rule says I can take the power and bring it down as a coefficient. Here we have 2 log of x. 2 log of x is the exact same thing as log of x squared. Here I could write this as log base 5 of x to the 4/5. If I apply the power property, I get 4/5 log base 5 of x. This would be 4 ln of x. So to kind of review some of the properties of log, some of these we've hit on before. Log base b of 1 is always 0, right? Log base anything of 1 is always 0. Log base b of b, in that sense, we can kind of think it cancels each other out, and we're left with 1. So that's where we got ln of e was 1. Log base b of b, that cancels out, and you're just left with p. That's the power rule, that I can take this power and move it to the coefficient, and then log base b of b is 1. So I'm only left with p. The same thing here, log base b of b to the log base b power, that's going to cancel out and you're just left with x. In 4.5, we're going to apply these to simplify expressions and solve for the missing value. It might be x, it might be a, it might be t, but we have to apply some of these. So we might raise both sides to the b to that power of both sides and simplify what we have left. And then we have the 3 we just learned here. Log base b of x times y is log base b of x plus log base b of y. Log base b of x divided by y is log base b of x minus log base b of y. And then the power property is saying I can bring that p out front and have log base b of x. So just like we talked about before, we can go from a single log to an expanded log. We can also take an expanded log and go to a single log. Here, a and b are in the numerator, so I take log of a plus log of b, subtract log of c. So let's look at some examples of combining all 3 of these properties together. And we're going to express them as a sum or difference. So we're going to expand them out, and we're going to have multiple logs here. I want you guys to try some of these. I can do them all day. Not gonna be tested on it. Did you get notes? Did you want notes?
Yeah, I've got it.
Oh yeah, okay, I did.
It's really cool.
Words with friends.
Yeah.
Taking the day off.
You only have to separate that. Mine.
Oh, no.
So log base 5 of 25 can be evaluated. You made the mistake here. Plus y, you can't simplify that.
I don't know, like, 'cause it doesn't make sense if you would minus.
So the 3 was good. The 5 only went with the y. So it only went with the y.
Oh, in front of here.
Yes.
So I need to move it.
Yes, but everything else is good.
So if it's only like,
Yes.
it's a single one term, I can stick it over
Yes.
here.
There's
Just the
nothing.
same as if there was more than just that, but whatever this is has to stick with its
Yes.
partner, but it can go to the front.
It goes to the front of it, but it stays with its y partner. So yeah, you'll have 3 terms in the first one.
2 in the second. Got it.
Okay, on this, do I, add or?
Is it in the denominator or the numerator?
It's the denominator.
So you subtract it.
X minus y to the 5.
Yeah, but the 5 can be pulled out front, have 5 log y. Log base 2 of y. Just like you had, okay, so you.
I don't understand that.
So this z, where did that 3 go?
Oh.
So it would be pulled up front. And then subtract log base x, which is good because it's in the denominator. This bottom one, yeah. So it's good. Here, can you rewrite this cube root? Here it would be 2/3, and on the bottom it would just be 1/3. Because the whole thing's under the cube root. And you're gonna do the same thing with the second set of them. You guys taking the day off too? So the first term is in the numerator, right? So I can write log base 2 of z cubed
Log base 2 z cubed.
Yeah. minus, because the second term's in the denominator, right? And there's 2 of them, so you're gonna have 2 minuses.
So do you do, that's what, yeah.
You have 1 minus,
One minus
and then another, yeah. If it's
So
in the
what
numerator,
about the 5, were you talking about a different
Yeah.
problem there?
no, it's the same problem. You can leave it, you can write it here, kind of, 1, 2, the 5 is only on the y, right?
Oh, yeah.
So what you're doing is you're pairing each one of these terms with a log. We're expanding that out. We have log base 2 of z cubed minus log base 2 of x minus log base 2 of y to the 5th, right? Z x
And then do the.
y. Okay, thank you.
First. Okay.
Why is the second one minus not plus?
Because it's still in the denominator. Yeah. So if I, like on this example, it's going to be ln of a to the 4th plus ln of b minus ln of c to the 9th. Then my next step would be to simplify it a little bit further. Here, I'm going to take 3 log base 2 of z, because I can, the 3 is only on the z, so it's only going to be on the term, the logarithmic term with z, minus log base 2 of x minus 5 log base 2 of y. Question on B? That would be correct. And then here, you can simplify, this log base 5 of 25 is 2, not log of 2. Log base 5 of 25, what power? Yeah, 2/3.
on that, after the x minus 5, is that 2 and then raised up and then x minus 5, all that is up on the same line?
Here, this log base 2 of y to the
No,
fifth.
below it, after the x minus 5 log 2 of y, is that all raised up against up above the 2? Okay, I'll just come up with this.
Okay, yeah,
See, okay,
let me,
see this right here, all this,
yes.
is that up above that, like all, it's not like, no, x minus 5 down here?
No, it's log base 2 of x
Okay,
minus 5 times log base 2 of y.
okay, so that comes down then, okay.
So my pen is fat, it's kind of hard to see. If I was to write this, this would be the 3 would go out in front as a coefficient, log base 2 of z, that's one term, minus another term, which would be log base 2 of x, minus log base 2 of y, oops, I'm going to take the fifth power out front, 5 log base 2 of y. So I've written one single logarithmic expression into simpler, 3 simple log expressions. If I knew what log base 2 of z was, log base 2 of x was, and log base 2 of y was, I can calculate this. Yes.
X and Y are both in the denominator, would that be plus?
It would be plus, but then the negative would be out in front. You would distribute the negative. You could write it like this, but this negative would go here and the negative would go here because they're both in the denominator. So you can think of it, if it's in the numerator, it's going to have a plus out in front of it. If it's in the denominator, it's going to have a negative out in front of it. Then you don't have to worry about distributing anything.
I don't know what you would be.
B is a little bit more complicated, but the first thing you want to do is you write each as a power. So I can say log, and in my numerator I'd have x plus y to the 2/3 divided by 10 to the 1/3. Right? Because the third root, I can just take the third root of the numerator and the third root of the denominator. The third root's the same thing as saying to the 1/3 power. So now what can I do? I could write 2/3 to the log of x plus y minus 1/3 the log of 10. And this is where I was trying to stress you. This is as far as you can break this down. You can't go further. A lot of times students will write that as log of x plus log of y, but you can't do that because you can only do that if they're being multiplied within the parentheses. You never break up an x plus a y. Yes, that would cancel. And what would I get? What's log of 10? 1, right? So I have 2/3. Maybe it's because I'm so zoomed in. I have 2/3 log of x plus y minus 1/3. 1/3 times 1. Okay, see that? So we're putting all these steps together.
Wait, why did you cancel out the log 10?
Because what is log base 10 of 10?
1.
1.
Where's the other log base 10?
Log by itself without anything underneath it, it's automatically assumed to be 10.
Yeah, it's understood to be 10.
Yes.
This like ln is understood to be log base e. So if it
Okay.
doesn't have a base, it's understood to be 10.
Okay, so that's.
So this next one, b here, I could write this as log base 5 of 25 to the 1/3 divided by a squared plus b squared, or sorry, 2/3. this is where I was kind of trying to emphasize earlier. Log of x plus y cannot be simplified. Log of x times y can be simplified as log of x plus log of y, but if your plus is what's inside your parentheses of your log, there's nothing to do. So here we get 1/3 log base 5 of 25 minus 2/3 log base 5 of a squared plus b. We're done there as far as the a squared plus b. We have to leave it like that. There's no way to simplify it. But we can simplify log base 5 of 25. Log base 5 of 25 is 2. We get 2/3 minus 2/3 log base 5 of a squared plus b.
So what happens to 1/3?
The 1/3?
Yeah.
1/3 times 2 is 2/3.
Oh, okay, yeah.
So these can look ugly, but with the right simplification, it's really easy to get rid of what you want to. And the same thing with some of these that are expanded. If we put them under one single log, it's really easy to evaluate. Let's look at writing logs as single. So we're going backwards. So what's log base 2 of 560 minus log base 2 of 7 minus log base 2 of 5? It's another way to write that. Log base 2 of 560, 7 times 5, right? Because if they're minus, if it's negative, it means it goes in the denominator. You always multiply though. You're either multiplying or dividing. So in this case, I divide by 7 and I divide by 5. Which gives me log base 2 of 16, which is 4, right? This is saying 2 to the 4th, it's 16. So where I couldn't have evaluated the left-hand side, simplifying it, I can evaluate and get my answer 4. What about B? Good, you guys see that? Log base 3. And then I have 54. The plus tells me it's times. The minus tells me it's divide by 20. So this would give me log base 3 of 27. What is log base 3 of 27? 3. Because it's 3 to what power gives me 27?
The only part that doesn't make sense is why you have. Oh wait, no, I just figured out. Never mind.
Generally, you're going to end up going from expanded logs to a single log, because when we want to simplify, what we can do is raise 3 to each power, or in this case, we're going to have something maybe equals x plus 10, and we want to solve for the x value. So we want to get all under one log, and then I can raise this side 3 to this side and 3 to this side, and it's going to be able to simplify and solve for an x value. So that's kind of eventually what we're leading up to. You'll need practice going both ways though. So let's look at A on both of these are a little more simple, and B, there's some things to simplify, like the difference of squares. So let's look at A, the first A. Write it as a single log and simplify if possible.
I put log of A cubed minus log of then with the square root of 2 b log c.
Okay, so I have log, and then I have a cubed, right? Because I'm taking this power and I'm pairing it with the a. Divided by, because the negative tells me divided by, b to the 1/2 times c to the 1/2. And then I can write that log of a cubed over the square root of bc. Since they're both to the 1/2 power, I can basically write a square root of b times square root of c, and you can combine them into one square root.
What? What you say?
This could be written as the square root of b, and this can be written as the square root of c
To get rid of the power.
to get rid of the powers. Generally things, but if you leave it as a power, it's fine.
So you don't have to dumb it down to that.
You
Like,
don't.
Leave it the other
You
way.
can leave it as b to the 1/2 times c to the 1/2, but it looks a little cleaner.
But if they're together like that and they're being multiplied,
Mhm.
square them both
Mhm.
and put them underneath the same square roots. of them.
Yes. So here we have log of x cubed divided by y to the 1/3 times z to the 2/3. And you see how the denominator is both 3? So I can actually write this as log of x cubed divided by the cubed root of y times z squared. Which looks a little cleaner than this. You guys see that? So on this one, you're putting the powers, you're putting the coefficients back as powers, you're writing the numerator in the numerator and the denominator in the denominator, and then you're simplifying. Here, I have ln. My numerator, I have x to the 1/2, so I'm going to write that as square root of x, times x squared minus 1 divided by x plus 1. This is where I was talking about simplifying. X squared minus 1 is the difference of squares. And I can actually write that as x minus 1, x plus 1. And you can see the x plus 1's cancel, and this simplifies to ln square root of x times x minus 1. And I might want to write it with parentheses so I know that's all within the ln. So you kind of see how this square root comes to the exponent seen here. This x squared plus 1 is in the numerator because it's a plus. And then this x plus 1 is in the denominator because it's minus. And then I just simplify within my parentheses. If I can cancel anything on top and bottom, I do it.
Feels a lot more complicated than they are in separate
You just have to know what to do. If it's a plus or minus, is it in the numerator or the denominator? Yeah. There's not a lot of interpreting these. There's
more memorization.
yeah,
of
it's
what's
more the properties in the process. Eventually, we'll apply this to solve for an x value that satisfies an equation. Right now, we're just simplifying.
Will you get it? Why is it 2 for the Z?
Here, That's a good question. See the two there?
Yeah. Yes, I don't know.
So, no, that's a good question. So you see the 2/3?
Yeah.
And this is a 2/3, right?
Yeah.
So when I pull out the 1/3 on both of these, I can take the square root. So the y has a 1, but the z has a 2.
Okay, so you're just left with this. I get it.
So we'll finish the rest of 4-4 on Monday. So we'll start here and look at more of these properties, and then we'll actually start to try to apply them. And I've kind of shown you guys this multiple times, this 4-5. This is what we're going to end up with. We're going to end up with solving for t. So if I take log of 1/5 of both sides, I can cancel my exponents, and then I have a linear equation, and then I solve for t. I will see you guys on Monday.
Mrs. Math teacher,
Okay,
will you tell me if this makes mathematical sense?
okay.
Because it looks to me like it does.